Swayam Prabha. Digital India. Educated India.
Welcome back. In lecture 43, we will continue with construction and demolition waste management. This is part 2 of the lecture. The different concepts that we will cover are on construction and demolition waste processing, the Burari model, reuse potential of C&D waste, siting and in-situ siting of C&D waste processing plants, environmental issues with C&D waste recycling facility, and then we will do a case study of Municipal Corporation Gurgaon. So, the first we will talk about the Burari model. We have talked about this in the earlier lecture as well. So, it is a pilot project initiated by Ministry of Urban Development, now Ministry of Housing and Urban Affairs, and this includes crushing units at Burari, which is Jahangirpuri in Delhi, and this is a C&D waste recycling plant. So, this was initially set up by the Delhi Municipal Corporation, but now it's a part of North Delhi Municipal Corporation. And along with IIFS, which is the Infrastructure Leasing and Financial Services company, they have thought of setting up this in the year 2009. Now, the agreement was done in PPP mode and on concession basis, and the agreement was initially for 10 years and eventually it was extended. Now, the 7 acres of land was given by MCD, and the land provided was to the company ILFS to operate on. And NMDC collects and transport the materials to the plant. So, that's the responsibility of the municipal corporation to collect the C&D waste and then collect and send it to the plant. And so, for that, skips and bins and hauled and dumper placers or hook loaders or tipping trucks are utilized. Standard waste collection equipment. And then the initial plant capacity was around 500 tons per day, and eventually it was expanded to 2000 tons per day. And mixed waste from 28 designated points in 3 zones of North Delhi Municipal Corporation was taken to this particular plant. So, as you can see, this is the plant operation, different operation going on different parts of the plant, and I will gradually discuss those. Around 95% of the C&D waste is recovered, is processed, and actually we can make it into other products, and it also uses water because some of the processes require water, and in this case recycled sewage water was utilized. Zero discharge, this entire facility is a zero discharge facility, but the technology they use is called a wet processing technology, which involves water at the end, so that the amount of silt and all contaminating the waste is reduced, and this also reduces dust and noise pollution from the material which are being processed or prepared from the C&D waste. Now, till 2016, as per estimates, around 45 acres of land which would have amounted to 400 crores saved by reducing landfill burden. Because we are processing C&D waste, that means we don't have to have more land required for landfill, and also it has given employment to the locals. In addition, of course, other money was generated by selling of these particular products. So, the process in this particular plant, you can see the different operations where the conveyor belt is carrying the crushed material, and then there are other cleaning facilities and all. This is the aqua cycle, you can say over here. So, waste is first weighed, how much amount of waste is coming in, then initially undesirable substances such as rags, plastics, metal, fiber, reinforced plastic sheets, all these things are removed. Then manual segregation of bigger plastic pieces. So, this segregation is either done manually and also using some amount of mechanical means as well. So, manual segregation is done for the bigger plastic and other pieces, whereas the metallic objects or ferrous, those kind of, or even non-ferrous could be used. We can use different forms of electromagnet to separate them, as we have learnt earlier. Non-recyclable materials such as plastic and wood that is recovered from this particular waste is sent to the waste to energy plant in Okla. which we have learnt about this plant in earlier case studies. The final waste after removing all this undesired material is what it remains are three categories of waste. One is whole bricks, which is used for internal use, or some whole bricks could be also sold. Then big concrete pieces and mixed C&D waste as per size. So big concrete pieces are chunks of concrete, whereas the other is a mix of bricks, concrete, and so this is mixed C&D waste, right? So again, this could be again subcategorized as per the size of those particular materials. Now, coming to the processing technique and methods applied. So there are usually two processes. One is the dry process and the wet process. So in both process, usually we remove the soil, the loose soil which comes along the C&D waste, that has to be taken out, and after that the C&D waste is crushed and screened, and it is done in multiple stages, and at different stages we get different sizes of products or different grades of product. Whereas in the wet process, what we do, that means even after all this processing in the dry process, because it's a dry process, still lot of silt and all these things remains in the final process products. So to get rid of this kind of silt or sand even in this particular products, so to overcome the loose soil and grit contamination of this particular product, the wet process is done. Now how it is done? So first, for concrete blocks and mixed C&D waste, for both of this, first these are broken using rock breakers. So this is the equipment that is used to break the waste into smaller particles. Then crushing by jaw or impact, which is jaw or impact crusher. It could be either a horizontal or a vertical shaft crusher, and it is based again on what kind of material, size of operation, and the final end use what we require, what kind of product we require. Depending on that, we will determine what sort of this jaw or impact crusher that we will utilize. And finally, we wash and screen. That means we wash the waste with water and then we screen the waste. And these are done by log washers, multi-layer vibration screens, Evo wash, Evo screen, thickeners, and filter press for silt removal. So this is where the washing happens, this is where the crushing happens, and this is first breaking happens, right? So after breaking, we crush it to making it into very small particles, and then we wash it so that we can remove the silt and those kind of materials. So sand is extracted. This is manufactured sand because we are crushing it into very small particles, and the remaining fraction is silt. So this is the final material which is coming out, and then whatever left is the silt part of it. So eventually this could be utilized for other construction purposes. So what are the final products coming out of this plant? So there could be road subbase, granular subbase, precast products such as carved stones, cement bricks, pavement blocks, hollow bricks, square tiles. Some of this you can see in this particular images, right? So then manufactured sand. So ultimately this is the manufactured sand, which is very small grain particles, whereas this is aggregates which could be used as granular subbase. So in addition, after cleaning, we are also getting rid of the soils, but the soil is there, which is also sold loose. This loose soil that we generate after cleaning can be also sold. So this is the different kind of products that are generated from this particular plant. Now coming to the final outcome of this project, because of this project, illegal dumping in Jamuna river and in the surrounding eco-sensitive areas were stopped, and the Supreme Court building and some member of parliament apartment buildings blocks were created using this kind of material. So 20 lakh tons of this material was utilized there. 4 kilometers of expressway by DDA was also constructed, where 2.6 lakh tons of this material was utilized. Then Delhi State Industrial and Infrastructure Development Corporation utilized 3.2 lakh tons of screened soil for the development of unauthorized colonies. So this is how this project has turned out to be a very good example which could be repeated in other parts of the country. So use of recycled aggregates could be use of this particular material. Definitely when we make aggregates out of this C&D waste, we reduce the natural resources that would have been otherwise used for creating these aggregates. One problem is sand mining from riverbeds, which is leading to erosion and flooding in certain areas. So this kind of practice will reduce the demand for sand mining. It will reduce the burden on the landfill site, the landfill area requirement, and finally it will enhance the conservation and saves overall urban land. So this is what are the general benefits of C&D waste. But now coming to specific kind of C&D waste like construction waste, demolition waste, reinforced concrete, calcium silicate bricks, natural stone masonry, you can see that these are the different processes which are adopted from that. For example, for ceramic tiles, we have to clean it and crush it, and then it could be used for flooring, cladding or aggregates. For demolition waste, of course, we have to crush and then sort it, then it can be used as recycled aggregate. Then clay bricks and roof tiles, this could be cleaned, crushed, sorted and pulverized, then it could be used for masonry or used as aggregate or mixed with lime to produce mortar. And then coming to this side where we have steel, we can recycle it and then we can clean and recycle it and then reuse steel components, and new steel components can be prepared from that. Aluminium, exactly same, we can recycle it completely. Then this reused beams, doors and this timber, wooden beams and doors, this could be cleaned and they could be reused directly, right? And then some plastics could be put into the plastic recycling streams of that particular ELV. The glass could be cleaned, crushed, recycled, and then we can have glass recycling streams as well. So you can see that a lot of material that is generated could be utilized in different ways, and not only the concrete and all these blocks, but also metals, glass and all whatever is generated from this kind of demolition sites or construction activities, we can actually utilize it for other or recycle it as we have discussed earlier. So then coming to siting of this kind of waste processing plants. So along with siting, we will also talk about in situ siting, that is wherever their demolition is happening, we can set up our processing plant over there, or in general terms where we will site. Now land use plan. So usually the town and country planning department or the urban development department of the state government is the one which is authority, which is department which is responsible for allocating land for these processing plants. Now usually the location choice depends on many things. It depends on logistics, it depends on land area available, it depends on what kind of emissions are coming out from the site. Is there dust emission, noise emission and so on. So those rules remain same for setting up any kind of recycling facility. Whereas in general, we will set up this kind of plants in industrial area, and at least it should be adjacent to a landfill site, so that whatever are the rejects could be directly taken to the landfill site. And if possible, we have to also go for in situ processing plants. This will reduce transportation cost and also the overall environmental burden. Now, one rule that is there in the management, the C&D waste management rules, is that we have to create certain buffer zones around this kind of processing facilities. For example, when plants are lesser than 500 tons per day, then the buffer zone should be 20 meters. Whereas if it is more than 500 tons per day, then we have to have a buffer zone of 30 meters around this particular plant. Now, inside the zone, we should also require a buffer zone. That is around 6 meters for a small plant, which is 500 ton plant, and 10 meters for a larger capacity plant. So the actual area that is available for operation or setting up some buildings is lesser than the site area that you will choose. So if I have a site area like this, actually we have to keep a buffer of 6 meter or 10 meter accordingly, and then create everything else inside this particular facility. So that is how you should determine what amount of area should be required to be reserved for this kind of setting up of this kind of processing plants. So if land is not available for buffer, because maybe it's a very densely packed area, or maybe there are other land uses surrounding where there are other industries also, which is not a problem in terms of emission and all this. In that case, the committee is formed, including people from CPC, the Pollution Control Board, Pollution Control Committee, who usually give recommendations on the final approval for setting up this kind of plants. Now, as we have discussed, in situ is always better because of reduction in transportation cost. So, National Building Construction Company NBCC has developed a in situ recycling C&D waste plant in one of its redevelopment site. This site is at East Kidwai Nagar in New Delhi. It includes 2,500 dwellings which needs to be redeveloped. So, there's a lot of C&D waste is generated because first you have to demolish, and for a waste crusher is set up underground so that dust and all these things doesn't spread too much. And then there is grinding and milling machines which make it into smaller particles and all, which is overground set up in this particular area. Now, there is also a brick making machine which makes sun-dried brick, which takes around 4 weeks for the bricks to mature. And standard size bricks are prepared, and these are used in the same buildings for development. That means in the same site they are doing lot of development where new buildings are being constructed. So, all these are utilizing the bricks which are generated over here. So, some of the environmental issues of C&D recycling facilities, these issues also remain for in situ plants as well. So, we have to be very careful. Now, some of these activities, there are different activities like site clearing, site operations, or contouring operations that permit water to be ponded on the site, or uncontrolled or poorly management site runoff, asbestos contamination. So, these are different aspects, and each of them results in certain potential issues, like site clearing results in dust and noise, loss of biodiversity maybe. Then site operations result in some, this ponding operations may result in some odor. Then uncontrolled or poorly managed site runoff results in transportation of sediments or erosion, which leads to water pollution and soil erosion. Similarly, in dust and noise leads to health, air pollution, ambience or visual impact, flora and fauna based on loss of biodiversity, they are impacted. So, transportation of materials to and fro from site and stockpiling of waste, recycling product, that leads to dust and noise. This is the primary concern. This leads to health problems, air pollution, ambience is also lost, and so on. So, sorting of C&D waste, hazardous waste components of C&D waste may cause health, air pollution and land contamination. And litter is spreading of the dust by wind and so on. So, it could lead to choking of drains and general littering of site, which is not aesthetically pleasing. Now, for this we have to regularly monitor this kind of sites, both in situ sites as well as separate sites. So, the ambient air quality monitoring standards has to be followed. These are again as per this suspended particulate matter, RSPM, then particulate matter, different kinds of matter are being measured, and you can see these are the values, acceptable levels. And similarly, for noise level standards, we have it's similar for industrial areas, and as given by CPCB during daytime, the maximum noise allowed is 75 dBA LEQ. So, this is the acceptable averaged decibel levels, and this for night time it is 70 dBA. So, this is what we have to be careful about when we are setting up this kind of facilities. And now we will do a case study of Municipal Corporation Gurgaon. So, as you can see in this particular image, this yellow are the real estate and infrastructure development projects that are going on in this particular area. Gurgaon is a fast developing area. So, we have got a lot of projects, but people, the waste that is generated from those projects are illegally dumped in nearby areas. As you can see from survey, these are the illegal dumping site that has been observed. These are empty sites, there are not too many people over there, so people are dumping waste there. So, this sort of practices has to be definitely stopped. So, it's not only making facilities for processing and all these things for C&D waste processing, but at the same point of time we have to deter people. So, that means there has to be some amount of penalty for this kind of activities, and also in cases people are doing construction, they are not informing the government, then there has to be definitely penalties. So, usually for non-disclosure, the penalty is around 25,000 or to 25% of the overall assessment of that property, whichever is lower. And night patrolling and alcohol complaints are registered. That means people can complain about if they see something, and night patrolling is taken up intensively so that people are deterred to generate this kind of C&D waste and then throw it away just like that. So that has been done in Gurgaon. So it's not only the positive things, but also some amount of strictness has to be there to prevent this kind of disposal activities. Now coming to the the processing plant that has been developed, approximately 1200 tons per day of C&D waste is generated in the Gurgaon Municipal Corporation, and usually earlier private contractors used to dump this waste in private properties. They used to sell it even for making those properties higher. Then illegal dump, the rest of the waste was illegally dumped along roads, public lands, and even isolated areas in the Aravalli Hills. So all this were done earlier. Then initially a C&D waste processing facility was proposed by the corporation along with ILFS, Environmental Infrastructure and Service Limited, which is ISISL. So this is a subsidiary of the ILFS company, and in year 2016 they had a build, operate, transfer agreement. This is one form of PPP mode agreement that you have learnt earlier. They have done a 20-year agreement for this kind of C&D waste processing, and initially they started with a 4-acre plot, and the plant was constructed and the plant started operating from 2019, and the design capacity of the plant was made around 1800 tons per day. So they started with 300 tons per day capacity initially, and then eventually they were able to increase that to the full amount of waste that is being generated in the municipal area. So one of the main problems with this kind of projects is the collection and the primary and the secondary collection system for C&D waste, because C&D waste is bulky, it is heavy, it's difficult to transfer. Plus it has to be done as per real-time requirement. That means somebody will book that my C&D waste has to be picked up from that site, and then we have to send vehicles. So all this detailed planning needs to be done. So Pragati Natural Resources Private Limited, so this was a company which was again taken under a concessionaire contract, and there they were paid around 360 rupees per ton for segregated C&D waste and rupees 720 per ton for non-segregated waste to collect and transfer this waste to the processing facility. Total they deployed around 92 vehicles and 23 machines, and total number of intermediate storage points that was used in the city was 5. Initially it was planned to be around 13, but ultimately 5 became operational. Total manpower deployed was more than 300, and total percentage of C&D waste that got processed is 100%. That means the entire 1200 tons per day of waste was actually processed. The process and method employed, as you can see, there is a crusher for the C&D waste plant. This is the Basai plant, and the process and method they employed was waste was initially inspected and weighed, and then computerized billing and vehicle tracking system, so that you can pay for payments and all this stuff. You have to measure how much amount of weight of waste is coming and so on. Then the plant has an unloading area where waste was unloaded, and then from that waste wood, steel, plastic and bituminous materials are manually segregated, and these are sold to recyclers. So this is the first waste stream. The 3 other waste streams that were there, because we have now segregated all these other materials, were whole bricks, big concrete pieces and mixed C&D waste. So this is almost same as the previous, this Burari plant. Then crushers were utilized where the concretes were broken into pieces. Conveyors were utilized for screening of this particular broken material, and then wet processing technique was utilized similar to the Burari plant for cleaning the waste, so that we can separate it from the actual different aggregates and the finer materials. So finally bulk contracts were done with bulk buyers to sell off this kind of material. So this is how these are 2 successful examples of C&D waste, and this could be repeated in many parts of the country. So these are some of the references you can follow. So to conclude, C&D waste collection and transportation needs to be planned carefully. An effective and smart C&D waste collection and grievance system with penalty goes a long way in making the entire process efficient and sustainable. Thank you.